All right, in this video, we're going to discuss a new concept, and that is the concept of outliers. So outliers are extreme values. They are data values that look like they may not belong with the rest of the data. And outliers are important for us to identify because they tell us a couple of things. One, it's possible that an outlier is showing up in my data set because I made a boo-boo as the researcher. My device wasn't properly calibrated when I took a measurement. There was a typo when I was transcribing my data into the computer. So outliers are a hint to the researcher to go back and double check and make sure there weren't any errors in our data collection or data transcription. Another important thing about outliers is if we've eliminated the first, and that is we've checked and we haven't made a boo-boo, outliers can be pointing to something new and interesting, new behavior in a system that we didn't expect, leading us to maybe change our research question, focus in on a specific subsection of the population, or modify our study in some other way to address why we're seeing that outlier. The other reason that outliers are important is outliers help us determine which measure of center and spread to use. And we'll talk about that in just a second after we talk about how to identify outliers. So there's a couple of ways to do that. In this class, we're going to focus on one rule. And in the 1.5 IQ, outliers and an upper bound for outliers. So these boundaries kind of enclose what we expect in terms of reasonable values based on our IQR, our measure of spread. Anything outside of these bounds is considered an outlier. So to calculate the lower bound, we're going to take our first quartile and subtract 1.5 times the IQR. For our upper bound, we're going to take the third quartile and add 1.5 times IQR. And if we are outside this range, we are an outlier. So let's try this with a set of sample data. So we have a list of sample data, 1, 1, 2, 3, 3, 3, 4, 6, 18. I want to check for outliers. So I know to check because those are the three moving pieces for my lower bound and my upper bound for the IQR rule. So we're going to go ahead and start values. And I can see 3 is my median. And then I'm going to go lower half, cross off, 2 in the middle. Halfway between 1 and 2 is 1.5 for my lower quartile. Same thing on the other side. Cross off, cross off. I end up with 2 in the middle. Halfway between 4 and 6 is 5. My IQR is going to be third quartile minus first quartile, which is 3.5. And I'm going to take these values and I'm going to calculate lower bound, upper bound. So my lower bound is lower quartile minus 1.5 times my IQR. And I'm going to grab my handy dandy calculator. So 1.5 minus 1.5 times 3.5, and I get negative 3.75. which is below my minimum. So there's no outliers on the left side. On the right side, we're going to take our third quartile and add 1.5 times our IQR. So 5 plus 1.5 times 3.5. And when I do that, I get 10.25. So my upper bound for reasonable data is sitting between 6 and 18. So 18 is an outlier. I could probably guess that just by looking, because 18 is 3 times bigger than the next biggest data value in my data set, and a gap that large, if I were to graph this, would be a good clue that there's probably an outlier just by a visual inspection of the graph. So the question is, what does this tell us about measures of center and measures in spread? So if the data or if it is heavily skewed, if one of those two things or both of them is true, we're going to use and we're going to use the IQR. If my data has no outliers, and is approximately symmetric, doesn't have to be perfect, but there's no strong skew. Ooh, sorry, my Apple Pen's being a little weird right now. In this case, we use the gold standard, which is our measure of center is going to be the mean, and our measure of spread is going to be the standard deviation. Most of the distributions that we're looking at in the second half of this course when we're doing inference, we're going to fall in this second group. We're going to be looking at data that's approximately symmetric, doesn't have any noticeable outliers. So most of this course, we're going to be using mean and standard deviation. If we encounter a data set that has noticeable outliers or heavy skewness, we should be over here. And that's because these data values are to outliers. And the reason they're resistant to outliers is these data values, or not data values, these measures of center and spread depend on where I sit in the list. Am I the first number in the list, the last number in the list, the third number in the list? But they don't actually care what the numbers in the list are. So an outlier just tracks as the last number in the list. It doesn't track as a big number, it just tracks as the last number, and what I want is the middle number. So this is not going to affect either of those very much. Both of these actually depend on the actual data value. I add them up to get my mean. Or they look at the data value minus the mean. And both of those are going to be pulled by any outliers in my data set. So if I've got outliers, median and IQR, no outliers and approximately symmetric, mean and standard deviation. All right, if you have any questions on outliers, feel free to send me an email. Otherwise, I will see you in our next video.